Hey everybody, Sarah at Nova Motorcycles again. So this week we're going to give a little update on the Velocette race motor that we did a video on a while back. Made some progress, not quite done yet, but if you follow us back into the engine room, we can tell you what we've been doing and where we're going to go from here. The goal, if you remember from the first video, was to find some better compression than the stock agricultural Velocette motor that I was building was giving us. We had the original cylinder, this big cast iron monster, and a flat top piston, and that only gave us 7-to-1 compression, and that is not going to be good enough for a race bike. Recapping the details of this. This is a 1951 alloy Velocette Mac 350cc motor. I put in a crankshaft from a 1930s probably Velocette MOV, which is a 250. It has a shorter stroke, so the concept here is to short stroke the crankshaft. To make it all work, I basically decided that I was going to try to fit a BSA 441 top end, a BSA Victor piston and cylinder in here, and this is what I've done so far. The crankshaft itself has been beefed up. Can't see all the goodies, but the crankshaft has a larger crank pin and a bigger conrod. Try to make it as beefy as possible, and we're going to do all we can to strengthen it up so it'll be able to withstand the higher revs that we're going to get put through this thing. So before last video, we hadn't done much of anything other than decide this is what we wanted to do, and we cut some stuff. We had a video of me cutting this thing to make it all fit, and so that has been a saga in itself, because as soon as we cut it, we got the jug on there, and then as soon as I realized, I start measuring to see what kind of mods we have to make to the actual height of the cylinder, then everything changes again. So what we did is we decided how much what's called squish that we wanted. Show this on here again. Now squish is the distance between the edge of the piston and the top of the cylinder head, this nugget here, and I want about 30 thou in there. So I measured that, did my math, and I cut the cylinder down so I'd have 30 thou of squish clearance. And as soon as I did that, all the cutting I had done, or some of the cutting I had done to make this fit, this jug fit on here, didn't work anymore because I had to move it all around. So you'll see this distance here is not 30 thou. That's more like half an inch, even 5/8 of an inch. So we need to cut this area down here, relieve the jug even more, so that these little stud holders will not interfere. Then it sits back down flat again. And another thing we did here is we cut the top of the piston, the edge of this, to make a squish band. It was a tiny little one. We chucked that in the lathe and we cut it inboard as far as we thought we needed to, and then beveled the edge of the piston so that there wouldn't be a hard edge. Squish is something that really improves the burning capabilities of the fuel. It basically does just what it sounds like. It's also called quench. A lot of English European people refer to it as quench. Basically, the piston comes up and the edge of that piston gets squeezed. This area gets squeezed real tight, so all the fuel in there gets shot towards the center. Literally gets squished towards the center, creates turbulence, moves the fuel back towards the spark plug and the flame front of the burn, causes more complete burn, much more efficient, and also more power. So we did all those mods for that. So now the next step is to fit the cylinder head and the push rods and all that, and then we'll turn over the motor and see when, I'm expecting it to hit, when the valves hit the pistons. We've also, because we shortened the jug, we shortened the push rods. So the push rods fit right here on top of these cam followers. Boo. Just have one of them there, but these had to be shortened because the whole barrel was shortened. Again, we took off about 28 millimeters total height of the stock motor, which is significant. It's over an inch. Another side benefit: shorter push rods are better, especially when you drop them. Shorter push rods are better because they're going to flex less, and that's again a place where power can get lost. the cam pushes up, and instead of opening the valve, it bends sideways. Your valve doesn't open when it should, as much as it should, for as long as it should. So a lot of different side benefits of this whole concept of making a short stroke motor. So that's about it for now. More fun is to come, but basically the next goal here is when these valves turn over, they're probably going to hit the piston, and I need to figure out how much they're hitting, and then I need to clearance the piston by fly cutting it, removing metal from the piston, just enough to get the right valve to piston clearance. So nothing on this is simple. Everything is just one thing leads to another. You cut one thing and then you get it right, and then you change something else and you have to go back and refit the other thing. But it's a lot of fun. It's really rewarding. And someday soon, this is going to be a very unique, interesting, high revving, hopefully, little race bike. So thanks for watching. Please like and subscribe and follow along.